7.4 Similar triangles. In 7.3, we learned a very important symbol to represent two similar polygons. This one is called a similar symbol. So let's review the symbol again. This symbol looks like a sideways S. Let's practice the symbol again here. So this symbol means similar. In 7.3, we also learned two properties of similar polygons. In two similar polygons, the measure of corresponding angles must be equal, or the ratios of lengths of corresponding sides must be equal as well. So for two similar triangles, they have exactly the same properties. The measure of corresponding angles must be equal, or the ratios of lengths of corresponding sides must be equal. Let's look at these two triangles. If I want to identify both of these two triangles are similar, I will find their corresponding angles. We can see that angle P corresponds angle S. Angle P equals angle S if these two triangles are similar. Angle Q corresponds angle T. So angle Q is equal to angle T. Angle R corresponds angle U. So these two angles should be equal. Or the ratios of their corresponding sides must be equal. PQ corresponds ST. QR corresponds TU. PR corresponds SU. So if I use those pairs of corresponding sides to form three ratios, those three ratios must be equal. Let's look at example 1. These triangles are similar. Justify your answer. Let's look at the triangle ABC and the triangle PQR. I will see that angle A is 75 degrees. In this big triangle, angle Q is 75 degrees. So that means angle A corresponds angle Q, and both of them are equal to 75 degrees. Angle B is 62 degrees. Corresponds angle R because they have the same measurements. So angle B equals angle R. Both of them are 62 degrees. Angle C is 43 degrees, as well as angle P. So angle C corresponds angle P, and both of them are 43 degrees. Right now we need to learn how to name two similar triangles mathematically. When we name two similar triangles, we order the letters to match the corresponding angles. Since angle A is equal to angle Q, angle A corresponds angle Q. If I put on A in the first place for the first triangle, I will put on Q in the first place for the second triangle. Angle B corresponds angle R, so B and R. Angle C corresponds angle P, so I will put on C and P in the same positions. Based on this expression, I can identify corresponding sides very easily as well. If I see AB here, I will see AB corresponds to QR. BC is the last two alphabets, so I will take the last two alphabets in the second triangle, which is RP. This one means BC corresponds to RP. AC was QP, so AC corresponds to QP. Let's look at example 2, using corresponding sides to name similar triangles. Identify similar triangles first. These two triangles are similar to each other. Can you tell this angle corresponds to this angle? Because they are equal. The reason why they are equal is they are vertically opposite angles. I can tell angle T corresponds angle P. They are a pair of corresponding angles. Angle S looks like angle Q. So angle S corresponds angle Q. After I identify all the corresponding angles, right now I can write down the first triangle in this way. For example, RST. If you decide the order for the alphabets for the first triangle. For the second triangle, I only need to look at which angle R corresponds to. Angle R corresponds to angle R. So I will keep the R in the first place for the second triangle. Angle S corresponds Q, so I will put on Q in the middle. Angle T corresponds to angle P, so I will put on P in the last position. And these two are similar triangles. You are given side lengths. Identify the corresponding sides from the shortest to the longest sides. Let's look at the first triangle, RST. I can tell the shortest side in this triangle is ST. The medium size is RT. The longest one is RS. So I will write down the corresponding sides for the second triangle. It's RQP. ST should correspond QP. RT should correspond RP. RS should correspond RQ. So right now, let's determine if those corresponding sides are proportional. The first pair is ST and the QP. ST over QP equals 6.0 meters over 4.0 meters. We can cancel the meters and then reduce this fraction to the lowest term. This one is 3 over 2. You also can change this fraction to the decimal. Let's look at the second pair. It's RT over RP. RT is 7.5 meters long. RP is 5.0 meters. Cancel the meters and then reduce the fraction to the lowest term. This one is also 3 over 2. The decimal value is 1.5. Let's look at the last pair. It's RS over RQ. RS is 9.0. RQ is 6.0. Let's reduce the fraction to the lowest term. This one is 3 over 2 as well. The decimal value is 1.5. So we can see that since the corresponding sides are proportional, these two triangles are similar. We also can see that triangle STR or RST is an enlargement of triangle PQR or RQP with a scale factor of 1.5. So because we take the small triangle as the original one, and we take the large triangle as the scale diagram. So we use the scale diagram divided by the original one to get the scale factor. We can use the properties of similar triangles to solve problems that involve scale diagrams. Problems that involve lengths that cannot be measured directly. Let's look at example 3. Using similar triangles to determine a length that cannot be measured directly. Let's look at the question. At a certain time of day, a person who is 1.8 meters tall has a shadow 1.3 meters long. At the same time, the shadow of a totem pole is 6 meters long. The sun's rays intersect the ground at equal angles. How tall is the totem pole? So let's find where are the angles formed by the sun rays and the ground. We can see this angle is formed by the sun rays and the ground. For this person, this angle is formed by the sun rays and the ground. And these two angles are equal. So I can write down angle C equals angle Z. So right now, let's think about something. The sun's rays form two triangles, with the totem pole, the person, and their shadows. If we can show the triangles are similar, we can use a proportion to determine the height of the totem pole. Assume the totem pole and the person are perpendicular to the ground. This one suggests angle B is a 90-degree angle. Angle Y is a 90 degrees angle. So angle B corresponds to angle Y because they have the same measurements. And as what we just analyzed from the condition, angle C and angle Z, they are two angles formed by the sun rays and the ground. and these two angles are equal. So angle B equals angle Y, angle C equals angle Z. If I take away these two angles from 180 degrees, I can get the third angles must be equal in these two triangles as well. So that means angle A must be equal to angle X. So far, we found that the corresponding angles are equal. That means these two triangles are similar. So triangle ABC is similar to triangle XYZ. Since we have two similar triangles, we can build a proportion which involves the height of the totem pole. So right now, let's identify the corresponding sides. I want to find how tall AB is. So I will highlight the side length. I definitely will use this length in the proportion I need to build up. And this length corresponds XY because they have the same positions and they look like each other. The other pair of corresponding sides is the shadow. BC corresponds to YZ. Both of them are shadow lengths. They are a pair of corresponding sides. So based on these two pairs of corresponding sides, I can make AB over XY equal BC over YZ. So this is the proportion I can build up. Then I can plug all the given numbers into this proportion. XY is 1.8, BC is 6, and YZ is 1.3 meters. They all have the same units, so you don't have to put out the units anymore. So I will write down this proportion separately. So AB over 1.8 equals 6 over 1.3. Let's find the missing length AB. If I want to find the missing length AB, I will use cross multiply. So AB times 1.3 equals 6 times 1.8. 6 times 1.8 is 10.8 equals AB times 1.3. Then I divide both sides by 1.3. So I can get AB is around. So the height of the totem pole is about 8.31 meters. Let's look at example 4. Using overlapping similar triangles to determine a length. A surveyor wants to determine the width of a lake, which is HN, at 2 points on opposite sides of the lake. She measures the distance and angles on land, then sketches a diagram. Find the length of HN, which is the width of the lake. So if I want to find the width of the lake, let's think about the first question. So first we need to identify two triangles in this diagram. Then determine if these two triangles are similar. We can use the corresponding angles to help us determine if these two triangles are similar. Two triangles can be identified very easily. The big one is triangle HNJ. The small triangle is PQJ. Let's isolate these two triangles. Angle H corresponds to angle P. They are the same. Angle N corresponds to angle Q. They are the same. Angle J equals angle J. This is a common angle that both of the triangles share. So I find all the corresponding angles are equal. Then I can determine these two triangles are similar. Let's name these two triangles properly. So the first triangle, which is the big one, I will write down HNJ. I just follow the order on the left side. So for the other side, I will write down, triangle PQJ. They are similar triangles. Since they are similar triangles, let's find the corresponding sides. We can tell HN corresponds PQ, NJ corresponds QJ, HJ corresponds PJ. We should have 3 pairs of corresponding sides. But among those 3 pairs of corresponding sides, you only know the side lengths for the yellow pair. So this yellow side is 210 meters, and this PQ is 230 meters. You can find the dimensions in this big diagram. So this proportion I can write down is HN corresponds PQ over 230 meters equals HJ. I found HJ is the total length of HP and PJ. So for HJ, I need to add 305 to 210. That's the total length of HJ. So PJ is 210. So let's solve this missing length in this proportion. I will find the sum on the top. So this 305 plus 210 is 515 over 210. So we will use the cross multiply to find the missing length HN. So HN should be equal to 515 times 230 divided by 210. We can use the scientific calculator to help us find the final value, which is 564.05 meters. So the width of the lake HN is about 564.05 meters.